Okay, so what happens in college, not music college, but every other college apparently, I don't know if it happens, it should, is they put you according to positions, okay? Instead of being grading you, your grades will only situate you in a position with respect to the highest and the lowest grade in the class, okay? So what's gonna happen is they do something called, they normalize your grades. What does that mean? I'm gonna explain with an example, and then we're gonna go into detail on how they do it, okay? Or how you can do it as well. At my old school, because of, this is gonna go public, I can't say, but at my high school, we were, my class, my grade was, we had 98 people. 98 people in 4 different sections. Out of those 4 sections, they always separated section 4 because they had a different curriculum. So it was 88 people. When we had midterms, we would take the midterms in the gymnasium. No shoes, or you had to wear sneakers so you wouldn't make noise. And it was all day, and the tests were multiple choice, and it was 2 hours, 2 to 2.5 hours. And we were seated according to grade. You never had your own grade next to you in front or on the sides or in the back. All of high school was in the gymnasium. So you would get your grade, and we spoke about topar las curvas. Nos gustaba topar las curvas. So if you had the highest grade of the 88 people, no matter what that grade was, you automatically had a 99. If, because it was according to percentile, I'll explain what that is. If you happen to be the poor soul that had the lowest grade, even if the lowest grade was passing, meaning they got a 61, but it happened to be the lowest of the 88 grades that they had, they automatically had a 35.
What?
And they would fail even if numerically they had passed, okay? That is because they normalized the grades. So what is that? What it is putting you according, it's called a percentile. You see the word percent in there, and percent immediately throws you to what number?
100.
To 100. So what they do is, they have these things called the z-scores. There's a chart already made, and they get the mean, the average, they get the standard deviation, and you find a number which is called the z number, and you go to a chart, and it will tell you what percentile you belong to depending on the average and the standard deviation, okay? So, at my school, it was, I'm sorry to say this, and I'm gonna say it on camera, but I can't. I knew that there were always gonna be 3 people under me that knew so much less than me. So I wasn't gonna fail. I wasn't gonna get the best grade, but I wasn't gonna fail. So it was, for me, it was easy. And then for math and physics, it was fun because we would compete to see who would get the highest grade so that we would get the 99, even if we hadn't gotten 100 or a 99, okay? That's what happens in colleges. In colleges, they put you ranked according to percentile, okay? So there's a national percentile, and if that's what they do when they put the 4.0 and that kind of thing. They're normalizing it so that you are in which rank, okay? They rank you. This is ranking, basically.
In your old school, if you got 100 and that was the highest grade, you would go down to 99?
Yeah, you never got 100. I don't know if it was a computer thing, but the 99 percentile is like the highest. The 100 percentile, it was 99 and 100 were like the same thing. It was insignificant, really.
You
Okay.
guys out in Guatemala?
Mm-hmm.
Can we guess the school?
No, I'm not on film. Sorry.
Can you tell us after the
Yes.
film?
Okay, so let's do this. The formula that you use is this. So the point of all of this is you are getting a position according, do you remember when we saw quartiles? Quartiles?
Mm-hmm.
Quartiles, you divided this into fourths. 1, 2, 3, 4. Fourths. And this is where the median was. Remember that the median is the equivalent to the second quartile? Remember that? First quartile, second quartile, third and fourth quartile. This one is in percentiles. So instead of dividing it into 4, it divides it into 100. Okay? So you're going to find that position within 100. The Z is, the X is the data you are trying to position within those 100. This would be my test grade. This data, let's put data. This is the mean. You remember what the mean is?
Yes.
The average, right? And this is the standard deviation. Do you remember what the standard deviation was?
Yes, the huge thing with the red square and the
It's how far away, on average, everybody was from the mean, okay? What do you do with those? Well, let's read an example and you will sort of find out what it is. It says, the mean weight, I'm doing example 70.1. The mean weight of the babies born in a metropolitan hospital for 7 years was 6.8 pounds. So the mean was 6.8 pounds. With a standard deviation of 0.8 pounds. If the distribution of the weights was approximately normal, that is really important. If the distribution is not normal, what does it mean to be normal? You're going to have those poor 3 souls at the bottom, those 3 happy souls at the top, and everybody else in the middle. Okay? That is a normal distribution. If you have everybody at the top, it makes no sense to do a curve, okay? Because everybody's up there. But if there's a normal distribution, then they do a curve. Especially if they have, let's say, out of the 88, everybody was below 60, for example. If everybody was below 60, even though that tells you that there's something wrong there, they can put it in percentiles, and then everybody's going to go, except for the poor 3 souls at the bottom, everybody's going to go and have a percentile which is decent, somewhere along the 70s, 80s, and the 3 happy souls with a 99, because they were the highest, even though they got a 61, 62, and a 73, for example, okay? So, if the distribution of weights was approximately normal, what percent of the babies weighed less than 6.4 pounds? Okay, so let's do the Z for this. You ready? The Z would be 6.4, which is the one you're finding, right? In this case, it's a weight. In the case of our tests, it was my grade. Minus the mean, which is 6.8, and that divided by the standard deviation, which is 0.8. And that gives me a number of negative 0.5. Okay, what do you do with that information? You go to the chart. I will give you a bigger chart, but for now you go to the chart on page 442, and I need Joanna to open her book, otherwise I need everybody on the chart. Page 442. Notice that you have the Z's on one side going down, and you have all the decimals on the top. going across. So, if it's negative 0.5, notice that you have negatives and positives. It's 0.5, isn't it? 0.5. So, on the top, you go to 0.5. You see it? And on the left, you've got the 0. Is it a negative 0 or a positive 0? Negative 0. So let's go to the 0 and the 0.5, which would give you 0.3085. Do you see it? So the z-score is associated to that one is 0. What?
3085.
3085. Okay. What is that? That is the percentile where it is located. Okay? So, if you look at the curve tells you that the mean is 6.8. And this one situates you at 30%. This is 0 percentile, and this is 100 percentile. Okay? So you are at 30.85. If this is 100 and this is 50, then 30 should be, this is 25, 30 should be somewhere here, right? 30.85 is where you put the, what was it? 6.4 pounds. What's the question? The question says, what percent of the babies weighed less than 6.4? 30.85%, right? Because this is where you are. 30% weigh less. How many weigh more than 6.4? 69.15, okay? Percent of that study. Is that clear? Is it clear how you find it? Do you want another one? Yes, Miss Sammy. I'm dying for another one. Okay, let's do another one. Okay. Let's do another. It says, what percent of the babies, for the same one, what percent of the babies weigh between 6 and 7 pounds? Between 6 and 7 pounds. For the same, what was the mean?
The mean was
6.8.
6.8 and
And
nations
0.8. Okay. So what do you think you do if you have to find how many are in between 6 and 7? You subtract. So first you gotta find the z associated to 6, and then the z associated to 7, and you subtract because you want to find that stuff in the middle. Okay. So let's see. Z1 would be 6 minus 6.8 divided by 0.8, and Z2 would be 7 minus 6.8 divided by 0.8. And this would be? Negative 1, exactly. And this one? Negative 1 over 4. So 0.25. We've got to do this in decimals.
0.25.
0.25. Okay. 0.25. Now you go to the chart and you tell me, I really want you to do it. I know it's in the book, but you can find it. Negative 1, what would that be? What's the z associated to negative 1?
0.1587.
Okay. 0.1587. And the one associated to 0.25?
57.
It would be 0.2. You would have to do the average between 2 and 3, right? Because you've got, in this chart, I'm going to give you a more